So, as we saw earlier in this course, we discussed the ideas of combinatorics which were first systematized under the notion of pratyayas in Pingala's Chandas Shastra. So, these ideas did develop in various other disciplines, and in the next almost millennia these ideas became much more complex, but more interesting in different subjects, and we are going to study this in couple of lectures. So, in this lecture we will study combinatorics in the earliest Ayurvedic texts, some ideas, then something about combinatorics in the text of Varahamihira. Then we will discuss in some greater detail another aspect of prosody. These are called the Matra Vrittas, what Pingala mostly considered were called the Varna Vrittas, the syllabic meters. We shall discuss the combinatorics or the idea of pratyayas in Matra Vrittas, and that will be a fairly detailed discussion, and very interesting mathematical ideas do come up in that. So, the ancient treatises of Charaka and Sushruta, they deal with combinatory questions in relation to various doshas and rasas. One of the most well known quotation from Charaka is the following, which discusses the 63 possible combinations that can be done from the 6 rasas. So, what are the 6 rasas? The Madhura, Lavana, Amla, Kashaya, Katu, Tikta, these are the 6, and different words are used here in Charaka for each of them at various places. Swadur Amladibhir Yogam Sheshaihi Amladeh Pratak, like that. So, Bhedas Chaisham Trishashti Vidha Vikalpo Dravya Desha Kala Prabhavad Bhavati Tam Upadekshyamaha. There are 63 Vikalpa. Vikalpa is the different possible combinations of these rasas, and that is what we are going to discuss in this. So, choosing 2 rasas out of 6, how many will come? Choosing 3 rasas out of 6, how many will come? Choosing 4 rasas out of 6, how many will come? And finally, choosing all the 6 rasas, how many possibilities? Then choosing only 1 rasa also, how many possibilities? So, these are what is discussed in those set of verses of Charaka. So, the 63 combination. So, obviously 2 rasas can be selected from a group of 6, that is 6C2, that turns out to be 15. 3 rasas can be selected in 6C3 ways, that is 20. 4 rasas is 6C4, which is same as 6C2. 5 rasas is in 6C1 or 6C5, that is 6. 1 rasa is selected in 6 ways, and when you select all the 6 rasas, that is possible only in 1 way. So, the total is 63, and this is just one particular case of the usual sum of all binomial coefficients NC1, NC2, etc. NCn is 2 to the power n minus 1. 1 plus 1 to the power n will have all these terms, and also the term NC0. So, without that this is. So, Sushruta Samhita also lists these 63 possibilities, but it does something more. It gives a sequential enumeration of these 63 possibilities, that is something akin to a prastara. For each set of combinations, they are listed in a particular way. Anyway, we will discuss such prastaras later. Now, going to an entirely different subject, this I hinted in the introductory overview. The discussion in Brihat Samhita of Varahamihira. Varahamihira is in the 6th century. He wrote 3 very important works: Pancha Siddhantika on the Ganita Skandha of Jyotish Shastra, Brihat Jataka on the Jataka Skandha of the Jyotish Shastra, and Brihat Samhita on the Samhita Skandha. These are the 3 different parts of the Vedanga Jyotisha, the Vedanga called Jyotisha. So, in the chapter 76 of Brihat Samhita, he is talking of the Gandha Yukti, the various ways in which perfumes can be made. In this chapter, there is a discussion of combinatorics. There is also a discussion of certain interesting discussion of certain magic squares. So, the magic squares topic will be taken up when that will be discussed in this course. So, he is talking of 16 basic perfumes Varahamihira, and then as a first thing that if you want to make perfumes by choosing 4 out of these 16, so how many possibilities are there, and that is of course the number of combinations that can be obtained by selecting 4 out of 16 and the standard 16C4. So today we will calculate this by doing this, right, 16 factorial by 12 factorial 4 factorial. So this is 13 into 14 into 15 into 16 by 1 into 2 into 3 into 4. So you will finally get that same number 1820. षोडशके द्रव्यगणे चतुर्विकल्पेन भिद्यमानानां अष्टादश जायन्ते शतानि सहितानि विंशत्या. So when we have these 16 basic perfumes, the number of possibilities when we are choosing 4, they will be 1820. Now a little later Varahamihira tells you how he arrived at this 1820. For that he is going to give you a Meru very similar to what Pingala did, but still it is a different Meru. The Meru is stated in a half verse, and then in the other half verse Varahamihira is discussing some other fairly complex topic. It is how to list all these possibilities. So supposing you are calling this as, just let me call them as perfume 1, perfume 2, etc., perfume 16, these are your perfumes. Now you are choosing some 4, so P2, P7, P12, P13 is one such possibility. But now there are 1820 possibilities, and as I said, once you have a combinatoric problem, you should give a rule to list all of them. So a rule to list all these combinations, and that is what is given. So a 1820 row array, and that is what is given in just this half verse of Varahamihira. The first half is discussing the Meru that we see. So as you can see, Varahamihira is not much more prolix than Pingala, that he gave the Meru in just the sutra Pare Purnam iti. So he is giving you the Meru in just Purvena Gatena Yuktam Sthanam Vinantyam Pravadanti Sankhyam. So one of the major commentaries on Varahamihira's Brihad Samhita is by Bhattotpala. He has commented on Brihad Jataka also. So Bhattotpala has explained in detail the construction of this Meru. So in the first column you just write the numbers 1 to 16. So in the second column you write sum of these numbers. So 1 is 1, 1 plus 2 is 3, 1 plus 2 plus 3 is 6, 1 plus 2 plus 3 plus 4 is 10, 1 plus 2 plus 3 plus 4 plus 5 is 15, 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. Obviously you do not need to do it that way. You have already summed up to 5, this is 15. So 15 plus 6 is 21, 21 plus 7 is 28, 28 plus 8 is 36. So like that you go on, and so Purvena Gatena Yuktam is that you start from the beginning and keep on adding. Sthanam Vinantyam Pravadanti Sankhyam. So you do not reach the last row, just finish before that. So Sthanam Vinantyam Pravadanti Sankhyam. Now the next column is sum of these sums. So 1 is 1, 1 plus 3 is 4, 1 plus 3 plus 6 is 10, 1 plus 3 plus 6 plus 10 is 20. So this column is done by sum of sum. This is 16C1, this is 16C2, this is 16C3, and finally this is 16C4, which is again sum of the sums. So that is the way of doing this, calculating the number of combinations. So again now this thing is based upon a different recurrence relation. The recurrence relation of Varahamihira is this: NCR is sum of n minus 1 CR minus 1, n minus 2 CR minus 1, etc., R minus 1 CR minus 1. And you can just, if you examine this, you can immediately see from this relation Pingala's relation follows. From Pingala's relation, if you just expand n minus 1 CR once again using the same rule, this relation follows. So both these are equivalent recurrence relations, but Varahamihira's Meru is different from Pingala's Meru. Both are simple ways of calculating the number NCR. but this formula that NCR is equal to various ways in which it is said, right, n into n minus 1 etc. up to n minus r plus 1 by 1 into r. So this is stated in mathematics books, this is stated in Lilavati, this is perhaps first stated in Ganita Sadha Sangraha. So this format of a formula for the NCR is given in the text of mathematics. They also deal with some combinatorics, but in other contexts they are just giving you this tabular method, and the table is equivalent to the formula. It's the table is based upon a certain recurrence relation, and Pingala's was based upon this, Varahamihiras is based upon this. And this sum of sums is, and this formula is a very, very important formula. Later on you will discover Narayana Pandita has discovered this formula for this repeated summation, and that is at the basis of much of the initiation into calculus arises out of this formula. So the entire, all these ideas are implicit already in Varahamihiras Gandha Yukti, in that Meru. Now we go on to the study of Matra Vrittas. So Matra Vrittas are again formed out of syllables only. Now instead of counting the number of syllables, we will start counting the total value, or in a loose sense the total time taken to pronounce the syllable. So a Laghu we will assign a value 1, and to Guru we will assign a value 2. So if you just take something like this, just take this Laghu Guru. So this has 4 syllables and each of them is a Laghu. Or if you take something like Ramachandra, so this is Guru, this is 2, this is 1, this is Guru, this is Laghu. Ndra is a Laghu, Cha is a Guru, because it is followed by a conjunct consonant. So in all there are 6 matras in it, there are 4 matras in it. So this way of doing poetry is not very common in Sanskrit. It became very, very common in all the regional languages, in Kannada, in Telugu, in Hindi, in Prakrit, essentially in Prakrit to start with, and in many, many regional languages. The meters, the prosody is based upon the Matra Vrittas, the number of matras that each pada is having, and then you have a combination where you have different matra units in a single foot of a meter. So Sanskrit also has that kind of a meter, and the most famous example is Arya, and the most famous example for mathematicians of a work which has versas in Arya is the Aryashtashati or the Aryabhatiya. Arya meter is a complex combination of matra units put together. It fixes the total number of matras in total number of units in each of the padas, composed of various matra units. There is something called the Vaitaliya meters also. So all these are discussed by Pingala, but Pingala does not give a detailed discussion of just Matra Vrittas alone. Matra Vrittas alone means you just fix the total number of matra, say each pada of your verse has this number of matras. So that is a much simpler sort of a problem. Pingala is discussing a more complex problem of Prastara and things like that with Arya and Vaitaliya meters. He calls some of them Gatha meters also. Anyway, let us come back to the definition of a matra meter. I have already told you, we will repeat it once again. A matra meter is, matra vritta is one where you assign value 1 to a Laghu, you assign a value 2 to a Guru, and you look for all possible metrical forms of a total number of matras. So suppose you had GLG as a portion, this has 5 matras. Now how many such metrical forms are there which have 5 matras alone? Of course the ultimate thing of course is LLLLL, all Laghus, that is also 5 matras. Now you have to list all the, so the first question is to start with a prastara of all such matras, matra vrittas of a given matra, and then start doing nashta, uddishta and all the usual stuff that Pingala has told us, that once you have a prastara what we should do. So one of the most important earliest works on matra vrittas is a work in Prakrit. It is called Vritta Jati Samuchaya. It is by Virahanka, whose name we will have to remember. We will soon see Virahanka is the originator of a set of numbers which we commonly think are called by the name of Fibonacci. Therefore, Virahanka is going to appear very often in our discussion. He wrote this work around 6th century. There is a commentary by one Gopala in Sanskrit. Then more detailed discussion of matra vrittas appear in Hemachandra. He is one of the great scholars in Sanskrit and Prakrit. So he has written Chandonushasana in 12th century. Then I mentioned Prakrita Pingala, Vani Bhushana, etc. We will quote some verses of these also for particular issue. So first is the prastara. So before going into the rule of the prastara, let us just see some examples. So one matra prastara is just a lagu. It cannot be a guru. Guru is two matras. So the two matra prastara, there are only two possible vrittas, a single guru or two lagus. Three matras, LG, GL, LLL. So what is the general rule for having a prastara of all such vrastas? So this is the simple verse of Virahanka, Yesha eva prastaro matra vrittanam sadhita kintu matra yatra na puryate prathamam sparsham tatra dehi. Sparsham means lagu, it is word for lagu. So the rule for matra vritta prastara is the same as the rule for varna vritta prastara. And in the end, if the matra is not completing, you just put a lagu. I will just explain it by considering, say, the four matra vritta prastara. So you start with G's. Of course, if it is 5 matras, you cannot have all G's, you have to have a L at the end. So you start with all G's from the right, and in the end, if necessary, put an L. That has to be the starting row. Now what was the earlier rule? From the left you start scanning. Whenever you find a G, put an L below. Carry whatever is there to the right below. Earlier the rule was in the left, fill it up with as many G's. There what you are filling up, the number of syllables were fixed, so you are filling up those many syllables. Now the syllables are not, number of syllables is not fixed. As you can see, a 4 matra vritta can have 2 syllables, 3 syllables, it can have 4 syllables also. What is fixed is the total number of matras, the total value. G is 2, L is 1. You add the number of G's and number of L's by that rule, that number should be the same. So in some sense it is what can be called as an ordered partition of the total matra by just 1 and 0, rather 1 and 2. So at this stage you have to add an L to have a total of 4 matras. Now again start scanning from the left, you have a G here, so next row you put an L here. In the left start putting G's, and you cannot put many G's, in the end you have to reach 4, so you have to put an L. So as I said, if necessary, put an L at the end. Next row, below this G put an L, bring down the L as it is, put a G in the left, it is over, 4 matras are finished. Again come down, put an L below this, put L's in the right, all that you can do is put an L in the left. So 5 matra vritta prastara, similarly, so we can take something, suppose you had some row like this, GLGG, LGG, something like this. How many matras are there? 2 plus 1, 3, 5, 7, 8, 10, 12. This is in the prastara of the 12 matra vrittas. So what do you do? Below the G you put an L, bring down whatever you have in the right as it is. But now the matras are not adding up, G has been reduced to an L, so you have to put an L in the left. That will be the next row. What will be the next row? Start scanning from the left, where G occurs put an L below, bring down the things to the right as they are. Now how many matras have we finished? 2 plus 2 4 plus 1 5 plus 2 7 plus 1 8. So we can put 2 G's to the left, because you are considering the vrittas of 12 matra length. Now again start from the left, this will become LG, LG, LGG, and you have to put an L to complete the total number of matra. So like this you have to work out the prastara. So the rule is the same as in the case of Varna Vritta. Start scanning from the left. When you encounter a G, put an L below, bring down the syllables to the right as they are. In the left, put as many G's as possible, and if necessary add an L, such that the total number of matras is fixed, at which you are the prastara for which you are the number of matras for which doing prastara. So the 5 matra vritta prastara is like this. It has 8 rows. The 4 matra vritta prastara had 5 rows. The 3 matra vritta prastara had 3 rows. 2 matra vritta prastara had 2 rows. Okay. This is the 6 matra vritta prastara. Start with GGG, end up with LLLLL, and this has 13 rows. So immediately you can see there is a pattern. You have these G's here in the first 5 rows. You have these L's in the next 8 rows. If you go behind, this had 5 rows, this had 8 rows. So all that you need to do to obtain the 6 matra vritta prastara is write the 4 prastara and write the 5 prastara below that, write 5 G's here, write 8 L's here. Obviously, because to the 4 matra vritta prastara, if you put a G on the right, it will become all 6. To the 5 matra vritta prastara, you add a L to the right, it will all again become 6. So the way to generate 6 is, they generate all the 4, generate all the 5. To the 4 you put a G on the right, to the 5 you put a L on the right. That will be prastara of vrittas of 6 matras. And so you can see that the 5 is constructed out of 3 and 4 in a very similar way. There are 3 rows in the 3 matra vritta prastara, those are the same 3 here, those are the same 3 here, or in the beginning, those are the same 3 here, you put a G to the right. There are 5 rows in the 4 matra vritta prastara, they are the same here, to that you put a L on the right. So this is the rule. So this is what our Virahanka is telling us. Dvau dvau purva vikalpau ya melayitva jayate sankhya sa uttara matranam sankhya esha nirdeshaha. So the number of rows in the n matra vritta prastara is given by the sum of the number of rows in the n minus 1 matra vritta prastara and the number of rows in the n minus 2 matra vritta prastara. Of course, we know that there is only one matra vritta of length. You hypothetically think of an S naught is equal to 1, and now you know what this recurrence relation means. This is the same recurrence relation by which what is called the Fibonacci sequence of numbers is generated, and so these sankhyas are just the Sn is sum of Sn minus 1 plus Sn minus 2. Why? The n matra vritta prastara is generated by first writing down the n minus 2 matra vritta prastara, below that the n minus 1 matra vritta prastara, write n minus 2 the Sn minus 2 number of G's there, write Sn minus 1 number of L's below, and therefore the number of possibilities of metrical forms of total value n is Sn, and those possibilities are Sn minus 1 plus Sn minus 2, and so the sankhyankas or the number of rows in the prastara of n matras are nothing but the numbers 1, 2, 3, 5, 8, 13, 21, 24, 55, 89. The numbers you are familiar in mathematics. These have been called Fibonacci sequence, because Fibonacci wrote down a problem concerning rats in his book. So now how to do Nashta and Uddishta. So we are going to call these numbers as Virahanka numbers, and essentially you will find that these numbers play the major role. In fact, in understanding Nashta and Uddishta for the syllabic meters for the Varna Vrittas, the number of possible metrical forms was given by 2 to the power n, and every number was represented as a sum of the powers of 2, and that is nothing but the what we now know as the binary representation of a number. Therefore, in going from the prastara to the row and from the row number back to the metrical form, the binary representation was the thing that came of hand. So, to do the same kind of problem with Matra Vrittas, you will see that every number ultimately will be related to the Virahanka numbers, or what are so called Fibonacci numbers, and they will play a role. So, what is the Uddishta problem? So, given a metrical form, how do you find out the row in which it occurs in the prastara? So, the rule is, for each G write 2 Sankhyankas, the first one above and the second one below, and for each Lagu just write 1 Sankhyanka above. Add all the Sankhyankas above the Gurus. This sum subtracted from the total Sankhyanka gives you the row number. Datva Purva Yugankam Guru Shirshankam Vilupya Sheshanke Ankairito Avashishtahi Shishtahi Uddishtam Uddishtam. Okay, this is from a very small book called Vani Bhushana. The first chapter in about 20 verses discusses the rule of prastara of both the Varna Vrittas and Matra Vrittas. This is written around 1500 AD, I think, by Damodara. So, an example will make it very clear. So, we can here we will do another example on the board. Let us see this example. So, the Sankhyankas are, these are the Sankhyankas, that is, these are the total numbers of the Matra Vrittas corresponding to each Matra value. So, for one Matra it is 1, 2 is 2, 3 is 3, 4 is 5, 5 is 8, 6 is 13. So, this sequence, the Virahanka sequence, is to be written down. Now, your GLLG is 6 Matras. So, this is a part of the 6 Matra Vritta Prastara. So, write 6 Sankhyankas, 2 for each Guru, 1 for each Lagu. The one that you are writing for Guru, write 1 above and 1 below. Write 1 above and 1 below, add the numbers above the Guru, subtract it from the total number of metrical forms for 6 matras, which is 13. What remains is the row number of GLLG in the Matra Vritta Prastara 6 matras. So, let us go back to 6 Matra Vritta. So, GLLG is 4, that is the row that we have. So, we can take anything else. So, let us take some other example of 6 matras only, LG, LG. Let us find out which row it is in the 6 matra. So, again 1, 2, 3, 5, I am sorry, 8, 13, right. This is how the Sankhyankas have to be written. Sum the Sankhyankas above the Gurus, subtract it from 13, so that is equal to 3. So, actually this would be the row just LG. Now, what is the logic here will become clear a little bit once we do the other process also. We did Uddishta first because the algorithm is very simple. Just write the Sankhyankas and write 2 for each Guru, add the numbers above the Guru and subtract it from the total Sankhya, you will immediately find. So, this is now being given to you like almost like a puzzle kind of thing, how this is occurring. Let us see the other way, that is the Nashta problem, and then we will be able to see some understanding of how this kind of an algorithm is arising. So, what is the Nashta problem? Given a number, we have to find out what is the Lagu Guru pattern in the Matra Vritta Prastara. So, take any number. If you want to compare it with what we did in the case of Varnavrittas, what were we doing for Varnavrittas? If something like LG we were talking about, so this is a 4 syllable Varnavritta, and what you did, you wrote 1, 2, 2 squared, 2 cubed, you added the number above the L's and added 1 to it, that is where that occurred. So, the Sankhyankas for Varnavrittas played a crucial role in analyzing the Uddishta problem for Varnavrittas. Now, we are doing it in a different way, because the nature of Matra Vrittas is that syllables are not fixed, it is some of the values of that is fixed. So, the mathematics of it becomes entirely different. Now, if you want to find out the Moric metric form associated with a given row number in the n Matra Prastara, first you write down n L's with the sequence of Sankhyankas above them, subtract the given row number from the last Sankhyanka Sn, from the result subtract Sn minus 1 if possible, otherwise subtract Sn minus 2 and so on till the end. The Moric form is obtained by looking at all those Sankhyankas which have been subtracted. So, as a statement of an algorithm, it is somewhat complicated, but if we look at an example, it will become very clear. It is also a fairly simple algorithm. So, 7th metrical form. So, first let me explain that looking at with the slide, then we will do another example on the board. So, the 7th metrical form in the 6th Matra Prastara again. So, write 7 L's, write the Sankhyankas above 1, 2, 3, 5, 8, 13. Okay. Now, we want to find the 7th, therefore, subtract this 7 from 13, what you are left with is 6. Now, with this 6, start looking at this from the right. What is the first number which can be subtracted from this 6? It is 5. So, this number 5, to use a word which we will be using later on in the combinatorics in music, you call that 5 as a Patita Sankhyanka, a number which can be subtracted, which is subtractable. So, 5 is the first number which can be subtracted, 8 cannot be subtracted, 13 anyway there is no question because the number of rows are much less than or equal to 13. So, 8 cannot be subtracted, 5 is subtractable. So, 6 minus 1, 5 is 1. So, you highlight this 5, then the number on hand is 1. Only this last 1 can be subtracted from that 1. So, there are only 2 numbers which are subtractable in that sequence of operations. So, there are 2 Patita Sankhyankas, there are 1, 2, 3, 4 Apatita Sankhyankas. Now, with each Patita Sankhyanka, the L below you mix it with the L to the next, make it a G. The L below this other Patita Sankhyanka, you mix it with the next L and make it a G. Rest of the things you leave them as they are. So, you will have a G here, you will have a G here. So, the metrical form is GL. So, GL is the 7th metrical form when you are making the Prastara 6 Matra. So, let us do some other example. So, let us do the 9th metrical form. So, again we have to do the same thing. So, 7 laghus we write 1, 2, 3, 5, 8. Oh, the 6 Matra Prastara only 13. Let us do a smaller number so that you will have more maybe. So, let us do the second row of this. So, to start with you do 13 minus 2 is equal to 11. Now, 8 can be subtracted. And now 5 cannot be subtracted, but 3 can be subtracted. So, this is a Patita, this is a Patita, the rest are all Apatita Sankhyankas. So, each Patita Sankhyanka you combine the 2 L's and make it a guru. leave the rest of the laghus as they are. So, this form is LLGG. So, LLGG is the second row in the prastara of, yes, LLGG is the second row in the. So, finally, what is happening? This number 13 minus 2, that is 11, you are writing it as 3 plus 8. Ultimately, this process is occurring by this decomposition of the number 11, this 13 minus 2, this number as 3 plus 8. And similarly, in that example that I had shown, what was happening? The number 6, we wrote it as 1 plus 5. Can you see something happening here? What is on the right hand side are the Virahanka numbers. So, every number below 13 can be written as a sum of the Virahanka numbers in a unique way if I put a certain condition, and that fixes the link between the prastara and the metrical form, the row number and the metrical form. That link is uniquely fixed by that kind of a decomposition of the number. So, even the Uddishta problem was very similar. The number 9 was represented as 1 plus 8. That was the way that Uddishta problem was solved. So, in the prastara, to link the row number with the metrical form, the mathematical principle that is operating is a certain decomposition of each of these numbers 1 to 13 as a sum of the Virahanka numbers 1, 2, 3, 5, 8, and that way of writing it is unique, and that is what I am going to say it here. Every integer, so for any 0 less than or equal to n less than or equal to Sn, or we can say all integers 0 less than or equal to any number k less than or equal to Sn, if you have this less here. So, each number k is equal to some S I1 plus S I2 plus etc. S IR, where I1, I2, IR are all less than S, are all less than n. So, take any Virahanka number, any integer less than that can be written as a sum of Virahanka numbers below that in a unique form, as long as you put the condition that the Virahanka number should be non-consecutive. So, non-consecutive means what? 1, 2, 3, 5, 8, 13, 21, 34, 55, right? These are the Virahanka numbers. These two are consecutive, these two are consecutive, these two are consecutive. So, ultimately the entire mathematics of the Matra Vritta Prastara depends on a decomposition like this, where every number is writable as a sum of the Virahanka numbers, where the numbers are non-consecutive. So, every number is either a Virahanka number, 8 will have only representation as 8, or if it is not a Virahanka number, it can be uniquely written as a sum, and that is what fixes you the row number, or it gives you the metrical pattern, the way to go from one to the other, and that is at the heart of the calculation. Now, last is Matra Meru, and Vani Bhushana is saying Matra Merurayam Durgaha Sarvesham Ati Durgamaha. So, there is nothing Durgama about it, it is also very simple, only it is slightly more complex than Pingala's Vardameru. But what is the question? That in a n Matra Vritta Prastara, how many metrical forms are there with any particular number of gurus, 3 gurus or 5 gurus or any particular number of laghus. So, to answer that question, that was called the Lagha Kriya question. So, for Pingala's case it was very simple, the total syllables were fixed, Each syllable can be either guru or lagu. So you are just picking out. So how many 8 syllable prastaras, syllable varna vrittas are there with 3 lagus? That is 8C3. There is nothing more to be done. But this is a more complex thing, right? Let us see the prastara there. You will see how the. So look at this prastara. How many matra vrittas are there with 3 gurus? There is only 1. How many matra vrittas are there with 2 gurus? It is here, it is here, it is here. So it is 3. And there is also one below here. There is 1, 4, 5, 6. There are 6. How many matra vrittas are there with 1 guru? So 1 here, 1 here, 1 here, 1 here. I think that is all. There are 4. How many matra vrittas are there with 0 gurus? There is just 1. So what about the lagus? How many 6 matra vrittas are there with 1 lagu? What is the answer? 0. Because there cannot be a 6 matra vritta with 1 lagu or 3 lagu or 5 lagu. Because guru will give you a 2. There has to be at least 2 lagus to make 6 in all. So whenever you have an even matra prastara, the number of lagus in that has to be even. When you have an odd matra prastara, the number of lagus there have to be odd. That condition does not apply to guru. So like that, this problem is more complicated. It is not just picking so many slots out of the total number of slots, but this was also solved fairly early, and this matra meru was written down. So this is the matra meru. So what this matra meru is doing? This is just the total number of meters. Total number of meters with 1 matra is 1. Total number of meters with 2 matras is 2. Total number of meters with 3 matras is 3. Total number of meters with 5 matras is 8. We saw all that. Total number of meters with 6 matras is 13. So these are all the Vidhanka numbers. So any row of this meru. So first thing, this meru has, unlike the simple meru of Pingala, which had 1 row, first 1 entry in the first row, 2 entries in the second row, 3 entries in the third row, 4 entries in the fourth row. This goes in a more complex way. First row is 1 entry, second and third rows have 2 entries, 4 and 5th rows have 2 entries, 3 entries, 6th and 7th row have 4 entries, like that. So 2 rows have the same number of entries. Then what other pattern you can see? It has 1 in the end, and if these 2 entries that you are having, the top one is always 1. That is also simple to see. The bottom one is 2, 3, 4, 5, 6, like that. That also we are able to see. If you want to see something more, then you have to take it from me. 10 is given by 4 plus 6, 15 is given by 10 plus 5, 6 is given by 5 plus 1, 21 is given by 15 plus 6. You go up 1 step, then you go across by 1 step. The sum of those two. So that is the recurrence relation. Now what are these numbers? So let us take the 6 matra vritta. 6 matra vritta prastara. So there is 1 metrical form with 0L, 6 metrical forms with 2L, 5 metrical forms with 4L, and 1 metrical form with 6L. Other way of talking about it, there is 1 metrical form with 3G, 6 metrical forms with 2G, 5 metrical form with 1G, and 1 metrical form with 0G. So each row of this matra meru is giving you how many different meters are there with a given number of lagus. It is also giving you how many meters are there with a given number of gurus. So how did they arrive it? Now first, how did they describe this meru? Dvayam dvayam samam koshtham kritva antyeshu ekamarpayet. Ekadvikat trikachatu kramena prathameshvapi. Shirsankapta parankabhyam sheshakoshthan prapurayet. Matra meru rayam durgaha sarvesham ati durgamaha. So this is Vani Bhushana. So they have 1, 2, 2, 3, 3, etc. number of cells in each row, 1 in top of each row and the end of each row, put 2, 3, 4, and finally Shirshankapta Parankabhyam Sheshakoshthan Prapurayet. That is how he is explaining to you the recurrence relation which we are now going to discuss. So, the question is, if you have an n matra vrita prastara, how many matra vrittas are there with I gurus? This is the question, right. So, how do we understand this? If there are I gurus, the total matras are n. So, I gurus will have 2I value. So, what is the value left out? N minus 2I. Therefore, if there are I gurus and we have n matras, so we have n minus 2I laghus. So, we have n minus 2I laghus. So, when we have I gurus, we will have n minus 2I laghus. This is fixed. I gurus is fixed, total matras n is fixed. So, if you have I gurus, there has to be n minus 2I laghus. Now, add these two, you have n minus I syllables. So, all those matra vrittas which have I gurus have n minus I syllables, and I of them are gurus. How many possibilities? N minus I Ci. So, that will tell you the number of matra vrittas of value n which have I gurus. So, I will repeat, if you have an n matra vritta prastara, it has I gurus, then it should have n minus 2I laghus because gurus have value 2. So, the total number of syllables also is fixed, it will become n minus I syllables. So, you have n minus I syllables of which I will be gurus. How many possibilities are there? N minus I Ci, and this I has to be less than or equal to n by 2. If you have n matra vritta prastara, you cannot have more than n by 2 gurus, each guru has value 2. Therefore, you have this relation. This is the number of matra vrittas of n matras with I gurus, and you can straight away see they will satisfy this recurrence relation. Gin is Gin minus 1 plus Gi minus 1 n minus 2. So, this number is the number above plus the number diagonally across to the right. 56 is 35 plus 21, 35 is 15 plus 20. So, that is how this matra meru is constructed, and it is one of the most beautiful constructions in combinatorics in ancient Indian mathematics, and a very nice combinatorial problem solved brilliantly. So, this was the first complexity that arises once you go from Pingala's fixed number of syllables and only laghu guru being there to a situation where fixed amount of total value, where guru has value 2, laghu has value 1. So, the number of syllables is not fixed, the total value is fixed. So, you do all the same things, you do prastara, nashta, uddishta and lagakriya. So, this is the beautiful mathematics of combinatorics developed in connection with the matra vrittas, and much of it is buried in literature and hardly discussed in mathematical literature in modern times. I mean, the older mathematicians did know what was being discussed. So, with this we will come to an end of today's lecture. Thank you very much.